All right, good afternoon, boys and girls. Excuse me. We're on lesson 62, estimating arithmetic answers with rounded and compatible numbers. So our objective for today is to round numbers to estimate the answer to an arithmetic problem, and we're also going to be able to use compatible numbers to estimate a solution to a problem. There's no vocab today, so don't worry about vocab. Just put your initials down so I know that you are watching the video. All right. Here's the joke of the day. Why did Romans always find math challenging? And it's because x always equaled 10. All right, so for our concept today, we have used arithmetic to find exact answers. And for some problems, finding an exact answer may take a few steps, okay? And it might take a lot of time. And so today's lesson, what we're going to be doing is estimating and using compatible numbers in order for us to save some time. And because sometimes you don't always need an exact answer, we can just kind of use about how much, or um, you know, about how much is the size. When we're looking for estimates, we're not looking for anything exact, okay? It's just we're trying to get close to a certain number. So in our example number one, we're going to estimate the product of 29 and 19. Now, if you remember what a product is um, the answer to a multiplication problem, okay? And so when we estimate, we're always going to look at a couple things. Where is the closest zero and where's the closest five? Um, and what I mean by that is like what can I turn this 29 into that has a zero, but it's close to it. So we're looking at tens in this case. All right, so we're gonna round 29 to 30, okay, because 29 is very close to 30. It's only one away. And remember, if we're over 5, then we're gonna go up. So we're gonna change the 2 to a 3, so this becomes 30. If we're below 5, I would go to 20, okay? And so 19 is very close to 20. It's only one away. And so it's easier to do a multiplication problem with 30 and 20, right? We know that 2 times 3 equals 6, and then add my zeros, that's 600. Okay, so that's a lot easier than having to do 29 times 19, where you do the whole multiplication algorithm. 9 times 9 is 81. Put down the 1, carry the 8. In this way, what we're doing is we're doing it. We could do this most likely in our head. 30 times 20 is 3 times 2 is 6, and then add my zeros in, which is 600. Is the estimate greater than or less than the actual product, and how do we know? Well, what we did is we moved our numbers to make them bigger, right? So because we made these numbers bigger, when we multiply them, they are going to be bigger. Okay, so our product is probably most likely greater than the actual product because we used bigger numbers than 29 and 30. All right, and so here's our solution to the problem. We estimate quickly to find out how much an exact answer would be. To estimate, we round the numbers before we do the work. The numbers 29 and 19 round to 30 and 20, and since which we can multiply mentally. Our estimated answer is 600. Since both 29 and 19 were rounded up to greater numbers, we know that 600 is greater than the actual product, right? Let's go to example number 2. We're going to estimate the sum of $8.95, $7.23, $11.42, and $6.89 by rounding to the nearest dollar before adding. All right, so what we're doing here is we're going to round to the nearest dollar. We don't want any decimal points before we actually add. Sum means add. So $1.95, there's only 5 cents left to get to $9. So I'm going to round this one to $9. $7.23 is lower. 23 cents is not half. So I would round down for the 7. And so instead of 7.23, it would be 7. Same thing with 11.42. Because 42 is not halfway to the 12 mark. what we're going to do is we're just going to keep this at 11. And then since 89 cents is really close to a dollar, we're going to round this up to 7. And then we're going to add. And let's look at what they have here: 9, 7, 11, and 7. Okay, now this is something easier to add together. What we can do, you could probably even do this in your head. 9 plus 11 is 20, plus 14 is 34. All right, and so for each amount, if it's 50 cents more, then we round up. If it's below 50 cents, we round down. All right, let's go to our next problem, which is example number 3. Estimate the perimeter of this rectangle by first rounding its length and width to the nearest 10 millimeters. Okay, so we are going to round this to the nearest 10. We're going to look at the 10 spot. So is it going to be closer to 7 or 8? And we know that it's closer to 8, so we're going to round this to 80 millimeters. And we know that this one's going to be close to 30 because we're going to round down. So now we need to find the perimeter. So if this is 80 and this is 80, we add 80 and 80 together, plus 30 and 30, which happens to be 220 millimeters. Okay, and so that's how you find the perimeter. Remember, the perimeter is the outside portion of any shape. And since we are just estimating, we don't actually have to do too much math. We just add our tens together. All right. Now, for some extra bucks or dojo points, tell me, how many centimeters is this 220 millimeters? All right. And if you guys figure that out, just remind me and make sure that I add my dojo points to your dojo points to your name, or give you some Google bucks. All right. Example number 4. An average cat weighs about 14 pounds, and an average porpoise weighs around 103 pounds. About how many more pounds does a porpoise weigh than a cat? All right. So what we're going to do with this one is we're going to use compatible numbers, and we're going to look for numbers that fit together well. Okay. So when we use compatible numbers, we don't necessarily have to round all the way to the 0. We're just looking for numbers that round, that work together, and so that I have an easy answer, that it's close to the actual answer, right? And so I know that 3 is very close to 4. Okay, and so what I'm going to do is I know that I can just subtract 14 from 104 instead of 103, because 4 and 4 make a 0. Okay, and then I have 10 minus 100, which equals 90. All right, and that's how you find out. That's how you use compatible numbers. In this case, is when it asks for compatible numbers, you know, you look for numbers that work together well to form zeros. Okay, and that's how you can use compatible numbers in this case. We could also round too. I mean, if you round this to 100 and this to 10, this would be also equal 90. Okay, so either way, if you want to round it to the nearest 10, which this would be 100 and this would be 10, you'd still come up with the same answer. You just have to make sure. Sometimes it doesn't work that easily, and you might get like a 5. Like 25s work really well with hundreds. So you got to think about what kind of numbers you're using in order to use compatible numbers correctly. All right, I know that's kind of awkward, but if you have questions, feel free to answer those. I'll write those questions down so I can answer them in class. All right, so here's your lesson practice for today. It's A through L. Estimate each answer by rounding or using compatible numbers before doing arithmetic. Okay, arithmetic's either adding, subtracting, multiplying, or dividing. And you may do the work mentally, but make sure you show which numbers you use to perform each estimation. All right, so like when you write down your problem for letter A, I'm going to give this one to you. If you're just going to estimate, what you're going to do is you're going to round this to 70. So write down 70 plus 40 on yours, and you get, your answer would be 110. Okay, so if you have any questions, write those questions down and we will talk in class. Have a great day and have some fun working on your math problem. All right, talk to you guys later. Have a good day.